So this is our main target for the day. We want to look at power rule, chain rule, product rule, quotient rule, and of course, we may go as far as looking at the implicit differentiation. So we'll start with these four, and then the fifth one, the implicit, then maybe we'll look at differentiation via first principle. Okay, so what is chain? Start with power. What is power rule? So power rule is where you're given the function y equal to ax to the power n, and they ask you to find the derivative of y with respect to x. So they want you to find the dy and dx. That means power rule asks you to multiply n by a, and then you subtract the 1 from n. That's the only thing that I'm going to do. Interesting, isn't it? But if your f of x, where I say y, I can as well say f of x. If f of x is g of x, okay, to the power n, then now you need to apply chain rule because g may be a function like x to the power 4 or something. So to differentiate here, you'll be finding the derivative of f with respect to x, which you can also denote like that. You multiply n by g of x in bracket from the power, you subtract the 1, then come back and differentiate g. You see? You first attack the power, drop it down, subtract the 1, and then differentiate another function. Right? Okay. And then product rule, well, you have the function f of x being given as u multiplied by v, where u and v are the functions just like where we use g. I could say g times h. Now to find the derivative df dx, you differentiate u and then multiply by v, and then differentiate v, then multiply by v. Okay. Where I put that cap prime, which looks like power 1, I mean differentiate. And then the fourth one, if you're having a function f, which is u over v, the derivative is going to be you differentiate u multiplied by v minus differentiate v multiplied by u, then divide by v, but it must be squared. These are the four main methods of differentiation that I use in everyday life. Anywhere you hear of calculus, that's what I mean. Okay. The fifth one is first principle. Differentiation via first principle. First principle says this. If you want to find the derivative of the function f, you will have to find the limit as h approaches 0 of f of x plus h minus f of x, and then divide by h. This method of the limit will give you the answers that you can get from power rule, from chain rule, from product rule, and from quotient rule. The other one is implicit differentiation. Implicit differentiation. Yeah, that's what I like. Uh, this is the case where we have a function maybe like this, y to the power n is equal to some function g. So maybe for some reasons you are unable to solve for y. Okay. Or maybe let me do this. Let me write it like this. Make it one like g of y is equal to maybe f of x. You see? So you have this g of y is some function of y, and you cannot make y the subject. So what you do is you differentiate y as a function with respect to y, and then multiply by dg dy. And then also the other side is differentiate. Okay? Meaning that at the end of it, they're going to have the derivative of g with respect to y is equal to f prime of x divided by the g prime of y, like that. So these are the methods, and this page summarizes the whole differentiation. Those who using this now, what remains is just to look for examples and start correcting now. Let me find examples. Examples.
So I'm asking for the previous page.
Okay.
All right, thank you.
Okay, question 1. What do you start saying? Find f prime of x from first principle. And f of x is equal to x. You see? You want to find the derivative from first principle, and we are given that f of x is equal to x. So you would show here you say that from first principle you would use the limit definition this one. So we say derivative is the limit as h goes to 0 of f of x plus h minus f of x over h. It's important to write the formula because if you mess up somewhere, you get the marks for the formula. Then this means the limit as h goes to 0, fx plus h will be the root of x plus h minus the root of x, which is f over h. Then we can conjugate the numerator. So you rationalize the numerator, you multiply by x plus h plus root x You also do the same down. Like this. So what is going to be the limit? As h goes to 0, this part here times this part here. So you have x plus h. So by now we are experts of rationalization. So you know what happens when you multiply that by that, that by that, that by that, but you only remain with x there like this. Then the denominator is intact. So now we see this x and that x will give us a 0. So we'll get 0 here. I want to do slow here. I don't want anyone to remain behind. I'm going to write like this. Okay. So we have this and that, so it remains with a 1 up there. So now that we are finding the limit, when it is 8, we take 0, so remain with 1 over the root of x plus the root of x, which is 1 over 2 multiplied by 1. Like that. Okay. That's how you find the limit. And that's a derivative. So the next one of A, B, f of x is equal to sin x. So again, it is going to be the limit as h goes to 0 of sin x plus h minus sin x over h. Using compound identity, we understand that this is going to be sin x cos h plus sin h cos x minus sin x over h. Meaning, we now have the limit as h goes to 0. We factor out sine here and we remain with cos h minus 1 plus sin h cos x. And so we can now divide by h here and divide by h here. The same thing. Okay. Then the next thing is we want the limit as h goes to 0. So this sin x is like a constant here. It can even come out. And then we remain with the limit as h goes to 0 of cos h minus 1 over h. And then plus even here, cos can come out. And the limit as h goes to 0 of h over h. Now we have two identities in trigonometry as far as the limits are concerned. The limit as x goes to 0 of cos x minus 1 over x is 0. And the second one is the limit as x goes to 0 of sine x over x is 1. So we want to use those identities here. Hang on.
I'm behind. Starting from the second step.
So the second step, we have sine x cos h plus sine h cos x minus sine x. And what we notice is that we are seeing sine x here and sine x there. So you could factorize. So we arranged it was like this: sine x cos h minus sine x plus sine h cos x. So because sine x is common here, you can factorize it. Then we remain with cos h minus 1. That's what we did there. And then the denominator, for as long as you carry the whole root of it, you can separate the numerator in any way that you want. So when you separate, we put over h here and over h here. Are you able to see that?
I mean, why isn't first principle?
Yes.
Then when you now differentiate, I know this is first principle, but how you now expand it from sine, then the bracket.
Look. How do you expand sine a plus b?
Oh, okay.
That's what we are doing. So a is like x and b is like h.
Okay.
So now, from the identities, we see that this one goes to 0, and this one goes to 1. So we're going to have sine x multiplied by 0 plus cos x multiplied by 1, which is going to be cos x. Okay?
So,
Uh,
yes, I wanted to ask, is this the first example? Maybe there are other examples that you studied with?
the first one was this one.
Okay.
the first bond. Then to content. And then the second body, that's an example. Another example here. Now that you're here, you can do another one. Example 2. Find f prime of x. F of x is equal to x squared plus 4x plus 3. This whole thing to the power 7 divided by equals sin x. Okay. So what method do we use here? It's a fraction. So we're going to use the most, so the holding method here will be quotient rule because it's a fraction. But again, you see, there will be chain rule because there's some function inside the power. Then there will be some power rule because of those things that are inside there. So we'll have to let u be x squared plus 4x power 3 to the power 7. And v will be sin x. So now I need to differentiate v. The derivative of sine is what we got here as well, as cos x. So we write cos x. The derivative of u we find now using chain rule. So we first bring down 7 and fix this. From 7 we subtract a 1, it becomes 6. And then multiply by, we differentiate x squared. Using power rule, it will be 2x plus. Using power rule again, 4 times 3, that is 4. And then x squared. Like that. So now we come to f prime. F prime is going to be u prime v minus v prime u over v squared. That is u prime is here, 7 x squared plus 4x power 3 to the power 6, 2x plus 4x squared, like that, multiplied by v. V is sin x minus v prime is cos x, multiplied by u is x squared plus 4x power 3 plus 7. Then divide everything by v squared, which is sin squared. No, because the rule says this. What does the rule say? The rule says you first keep G. Yes. And then you come back and differentiate G. For the first time, it won't be differentiated. The second time, that will be differentiated. So inside chain rule, there's some there's some power rule there. There's some quotient rule in one question. We need to get used to such. That's how questions are mostly asked. Actually. You see? Some more examples, maybe you need them. Let's look for some more examples. Question 3. Use implicit. Use implicit differentiation. To find y dx given x squared plus y squared plus 8x minus 2y minus 8 is equal to 0. Solution. So to differentiate using implicit, as you can see here, it looks like we may not be able to solve for y. Make y the subject. There will be so much work involved if you want to do that. So the best is we just differentiate here. So we differentiate x squared, we'll get 2x. Differentiate y squared, we get 2y. And then multiply by dy dx. Remember, whenever you multiply the y part, whenever you differentiate the y part, you have to multiply it by dy dx. And then differentiate 8x, we get 8. Differentiate 2y, we get 2. But because it's y, we also write dy dx. And then differentiate 8, we get 0. We differentiate 0, we get 0. Now, because we want to find dy dx, so you factorize dy dx. It's dy dx is dy dx. So you factorize it. So you say dy dx. It's common, right? Now, what remains is 2y minus 2 is equal to minus 8 minus 2x. Then divide by 2y minus 2. Divide by 2y minus 2. So we have dy dx equal to minus 8 minus 2x over 2y minus 2. Okay. This is what we call implicit method. So we have used the implicit differentiation to find this solution. And the solution is
So did you differentiate those? So that part which has 2 dy dx, did you differentiate it separately there?
this
I'm
part.
a bit confused there.
So we
Yes, and the other one.
differentiated. Look, we differentiated 2y with respect to y. So we got 2 minus 2. But because the rule says when you differentiate the y part, you must multiply it by dy dx. So now you multiply it by dy dx. You see? That's why it's minus 2 dy dx.
Yes, on that one, I got it. I mean, those two parts, there's 2x plus 2y dy dx, and those two which is 8. So now when differentiating those, you said you're factorizing the dy dx there, and then yes, on the factorization now, that's where I'm a bit behind,
So to
because I can
factorize,
see a quotient there, which
we're dividing to make dy the subject. So because dy dx is common, you put it out, dy dx. What remains? Here you remain is 2y. There you remain is 2. Equal to whatever remains, we take the other side. So we have minus 8 minus 2x. We want dy dx to remain alone. So you divide this part which is multiplied. You divide on both sides. So that these comes.
oh,
And
all
then
right,
the dy
all
dx
right, right. I got it there. I got it. Yeah, I understand now.
Okay, so you see, no much issues here. So what's key is just knowing the method. Here. This is what is key. So we meet again tomorrow. We do the same. So today we have this method. So you look at them, look at the examples, you got the choice, solve issues there, and then see if you understand. When you come back, it will be interesting because next thing now that we are doing is I wanted us to do integration, but then I realized that we haven't done binomial. So we post calculus there. So tomorrow we'll do binomial. Yeah. After binomial, we'll come back and do integration. So differentiation really is nothing much. I was just meaning to differentiate now specific functions like exponential, log, some difficult trig, and then also we'll do integration. But that will be done after binomial. So tomorrow we're doing binomial. So maybe tomorrow we'll have maybe a 2-hour session because binomial is a bit long, but I want us to finish it in one session. Because the things talk about are not a lot. Maybe just need more examples. So if you miss tomorrow, it means you would have missed binomial. Then you don't miss. Because a video may take time to show up in the group, as it is the situation at the moment. Otherwise, start well.